Welcome, your grade A mathematics teacher, Beatrice here. Today we are talking about moments. And I would like us to start by saying that one helpful approach to finding the summary measures for distributions is based on what we call moments. So we are going to discuss three types of moments. We will have one, moments about the origin. We have moments about the mean, and we have moments about a point. We have moments about a point. So we start by giving some definitions. So I'd like us to write definition 1. And we say consider a random variable x which ranges from x1, x2, all the way to xn. We can get the mean for these xi's as they are. We can get the mean of their squares. We can get the mean of their cubes. And that is what we want to see now. So I would like us to write that x bar raised to power n. As we have seen, we are looking for the mean of the powers of these xi's. Will be x1 raised to power n plus x1 raised to power x2 raised to power n plus all the way this is actually m, not n, all the way to xm raised to power n. And because we have x1, x2, all the way to xm, if we'll get the mean by dividing that by m. And because in statistics we like to use the shortened form, we can say that x bar n is the sum of the xi's raised to power n from I is equal to 1 all the way to m, because there are m of them, or that divide by m. So what we have written there is what we call, so we say this is the nth moment. It is the nth moment about the origin. The nth moment about the origin. We can look at an example. Suppose our xi's are x are are 10, we have 11, and we have 12. Now, x bar is going to be 10 plus 11 plus 12, all that divided by 3, and this should give us 11. I hope you can see that this is not just x bar, but it is x bar raised to power 1, because each of these are raised to power 1, to power 1, to power 1. And this actually gives us the mean. So x bar, can call it x bar raised to power 1, is the mean. It's actually what we call the sample mean. So suppose we square them. We can get the mean of their squares. It is 10 squared plus 11 squared plus 12 squared, all that divided by 3. And if you divide that, you should get 121.67. So you can see now, this is the second moment. It's the second moment about the mean. The second moment about the origin. It's the second moment about the origin. As you're going to see, we are saying it's about the origin because we are actually subtracting just 0. We are subtracting nothing from the scores. Now we write definition 2. And in definition 2, again we consider x1, x2, all the way to xn. And we say the rth moment about the mean. The rth moment about the mean. Of course, you know the mean is x bar, is given by the rth moment about the mean is given by, we use this symbol mu r, and we say is equal to the sum. I is equal to 1 all the way to m of xi. We subtract x bar and we raise that to power r, and we divide that by m. So this is what we call the rth moment, and we are calling it the rth moment about the mean because from each of the xi's we subtract x bar. And we can look at an example. If our xi's are 10, 12, and 13, our xi's are 10, 12, and 13, we know that the mean is 10 plus 12 plus 13, all that divided by 3, and we get 11 and 2/3. Now, if we take each of the scores and we subtract the mean and we sum through, we can say 10 minus 11 and 2/3. We add to 11 minus 11 and 2/3. And we add that to 13. So this is 12, not 11. This is 12. 13 minus 11 and 2/3. If we sum that through, we should actually get 0. So the sum of deviations from scores from the mean is always 0. So we say that the first moment about the mean, the first moment about the mean is 0. The first moment about the mean is 0. And we can actually prove this. We have seen that mu1 is the sum from I is equal to 1 to m of xi minus x bar. All this divide by m. So if we remove the brackets, we are removing the brackets. Let's see, have it here. We have mu1 is equal to the sum from I is equal to 1 to m of xi divided by m minus the sum I is equal to 1 to m x bar. All this divided by m. So what we basically are going to have is that mu1 is equal to, first of all, allow me just to write that, xi over m minus, because x bar is a constant, we take it out. So we are going to have sum of I is equal to 1 to m. We are left here with 1, and we divide that by m. Now, if we sum I is equal to 1 to n, if we sum 1, m times this figure that we have, sorry, just this that we have there. If we sum 1, m times, we are going to have m. So what we are going to have is that mu1 is sum of xi over m. I is equal to 1 to m minus x bar. This becomes m over m. So we are actually going to have this equal to sum of xi's divided by m is actually the mean minus the mean, which is equal to 0. Because this m and that will cancel. So we conclude that the first moment about the mean is 0. The first moment about the mean is actually 0. Now let's talk about the second moment about the mean. So second moment about the mean. Second moment about the mean, we would write it as mu2 is the sum I is equal to 1 to m of xi minus x bar. Because the second moment we are squaring, all that divided by m. And if you look at that, it is actually the square of, it is the formula for variance. It is actually the variance. So the second moment about the mean is the variance. Second moment about the mean is the variance. So far we have looked at definition 1 and definition 2. We have looked at definitions 1 and 2. We have looked at the first moment. We have looked at moments about the origin. That was the first definition. Then we have looked at moments about the mean. So now we look at moments about any point A. So we write that as definition 3. We say the Earth moment about any point, the Earth moment about any point A is defined, as, this time we usually use prime, so we write mu r prime is the sum from I is equal to 1 to m of xi minus a raised to power r, and all that is divided by m. Let's look at an example. We say our x's again are 10, 12, and 13. And we take A as 10. So we want to get moments about the point 10. So the first moment about 10 is, we take 10, subtract 10. We add 2, 12, we subtract 10. We add 2, 13, subtract 10. And all this we divide by 3. And if we do that, we are going to get 1 and 2 thirds. So that is the first moment of those points about the point 10. So I'd like us to conclude by looking at a few examples here. So example 1, we say find the first, second, third, and fourth moments of the set of numbers about first of all the origin, about the origin. So what are our xi's? There are 2, we have 3, we have 7, we have 8, and we have 10. So we want to get the moments about the origin. So the first moment about the origin is simply going to be 2 plus 3 plus 7 plus 8 plus 10, or that divide by 5 because we have 5 items of data and we have 6. So we call it the moment about the origin because from each of the scores we are subtracting 0, which is the second moment. Still about the origin is what we call x bar squared, and it is 2 squared plus 3 squared plus 7 squared plus 8 squared plus 10 squared, or that divide by 5. If you work out that, you should get 45.2. That moment, still about the origin, is just about raising the numbers to power 3. 2 raised to power 3, 7 raised to power 3, 8 raised to power 3, 10 raised to power 3. All that divide by 3 and you get the answer. And x bar 4 is going to be simply 2 raised to power 4 plus 3 raised to power 4 plus 7 raised to power 4 plus 8 raised to power 4 plus 10 raised to power 4. All that divide by 3. So those are moments about the origin. What about moments about the mean? We look at an example here to do with moments about the mean. So we find the first, second, third, and fourth moments of the following sets of numbers about the mean. We have number 2, 3, 7, 8, and 10. What is the mean of these numbers? This is 5 plus 15, 20, 30. 30 divided by 5, so the mean is 6. So mu1, which you're going to work out, is 2 minus 6 plus 3 minus 6 plus 7 minus 6 plus 8 minus 6 plus 10 minus 6. All this divide by 6. And you can be sure when you work out that, as we say, that the first moment about the mean is always 0. What will be mu2? It will be 2 minus 6 squared plus 3 minus 6 squared plus 7 minus 6 squared plus 8 minus 6 squared plus 10 minus 6 squared. So that will be the second moment about the mean, or that divided by 6. And it will be the same for mu3. We raise to power 2. And for mu4, we will raise to power 4. So if you work out this, you will actually get 9.2. So I'd like you to work out mu3 and mu2, in which case you are simply taking 2 minus 6, you raise to power 3, 3 minus 6 raised to power 3, plus 7 minus 6 raised to power 3, 8 minus 6 raised to power 3, plus 10 minus 6 raised to power 3. All that you're dividing by 6. And the same case applies to 4. So what have we looked at today? We have looked at moments. We have talked about moments about the origin, moments about the mean, and moments about a point. So what we are going to look at the next time is formulae that relate the 3 types of moments. And as we are going to see, we usually use the moments about a point to get moments about the mean, which are actually the useful moments, because they are the ones that give us the mean. They give us the variance and even other higher moments. So we continue from there. Thank you.